Okay, this is the notes on division law of exponents. We've already talked about multiplication, that when you have the same base and you're multiplying, you add exponents. Well, this one, when you're dividing the same base, the same large number, then we're going to subtract exponents. So think about you're making the number smaller, and so you want the exponent to be smaller. So here, if you will write these out, it will make these very easy to see. We have b to the fifth, 1, 2, 3, 4, 5. b to the third, 1, 2, 3. Anytime you divide the same number or letter by itself, it's going to cancel out. And so when we divide this, we end up with b to the second. So on your papers, change this to b squared, because that was a typo arrow on there that said 7. It should have been 5 minus 3 for our exponent gives you b squared. So the rule tells us that for any non-zero number b, which means it can't be 0 on the bottom, because if it's 0 on the bottom, it's not going to be able to be divided anyway. It would be an error message or be undefined. So anything else, for these two, where m is bigger than n, we can subtract. And this is where it tells us that the base cannot be 0 because the division would be undefined. So let's look at these examples. And we're going to write each one of these out. I want to see these on your paper because it makes it much easier for you to see what cancels out and what's left over. 1, 2, 3, 4, 5, 6, 7. In the bottom we have 1, 2, 3, 4, 5. Each pair, top and bottom, will divide out, and we're left with x squared, which is the same thing we would have if we subtracted our exponents. 7 minus 2 gives us, 7 minus 5, gives us 2, which is x squared. Number 2, again, if there's nothing there, it's understood to be 1. So we have 1, 2, 3, 4, 5 y's on top, 1 y on the bottom. You need to ask yourself on these which one has more. Most of the ones you're going to look at here, the top will have more variables on it, but if there's more on the bottom, that's where it has to go. We can't just move them because you don't want to write it as a fraction. So here, y's cancel, and we're left with 4, which is the same as 5 minus 1, is y to the fourth. Same thing if everything's in parentheses. Whatever's in parentheses has to stay that way. It's connected together. You either cancel all of it or you cancel none of it if it's in parentheses. So if we have 3 a plus b variable sections on the top, expressions, we have 2 on the bottom. These cancel out. You're left with a plus b to the first, or you can simply write it as a plus b. We can't have a mixture of numbers and letters. We have 3 a's and 6 b's on the top of our fraction. We have 2 a's and 3 b's on the bottom. You can only cancel like terms together. So we can cancel the a's, we can cancel 3 b's. We're left with 3 minus 2 is a to the first, 6 minus 3 is b to the third, and sometimes you may see it written without the 1. We know that those are the same thing. A, b to the third. And that's our basic division law of exponents. So same idea that we did with the other one. We can write these in numerical form, or we can write this as an exponent. Kind of depends on how large the number is. If we start out with 2 to the 9th over 2 to the 6th, if we take our law, it's a little bit of a shortcut, and we subtract, we end up with 2 to the 3rd. 2 times 2 is 4, times 2 is 8, or we get 8. So that one's not going to be very large. There's understood 1. 5 to the 4th minus 5 to the 1st is going to be 5 to the 3rd, which is 125. And now I have my calculator here. Does everybody know how to put, make sure you know how to put the exponent in your calculator? If you were going to do this and check it, I want you to write the steps, but you could also say, for example, on this one, 5 to the 4th, 5, and here's our exponent key, to the 4th, And I don't think you have to move yours over. This one's a little bit newer, but if you do, make sure you're on the large number here, for those of you that have your own, and divide it by 5 to the first. And so that tells me my answer. So we should be able to check these with the numbers in them. The reason we know the law is because sometimes if we don't have the letters or don't have the numbers, we have letters instead. You need to know what you would end up with, and you would have to leave it with the exponent there. Okay, so here we have the negative again. Same thing applies with the other one. Negative's in parentheses, so it has to stay in parentheses. This is negative 2 to the second power, which is 9, because 5 minus 3 is 2. That would be different if we look here at the bottom. This would be different if I had negative 3 to the second power with no parentheses, because this is negative 3 one time times the other 3, because the exponent only applies to the number or letter directly before it. So this negative is stuck out here by itself. So 3 times 3 is 9. Put the negative on it. So if this negative is not in parentheses, then we have to add it onto the end. If it is in parentheses, it follows the rules that we've talked about before. An even number of negatives gives us a positive. An odd number of negatives gives us a negative. Okay, so for number 8, we have four threes on top and 1 3 on the bottom. So 4 minus 1 gives us 3. So we have 3 to the third. Then we can look at our 2's. 5 minus 4 gives you 1. So then I could put this in the calculator. I could say 3 to the third, 3, exponent, 3, and then times 2. You don't have to put the exponent of 1, you can, but it's just going to be the number itself. Gives us 54. Okay, if we have large numbers in front that are not the same thing, this says coefficients. Remember, those were our numbers in front of our letters. If we have coefficients, they have to be divided, just like we had to multiply them on the other. Exponents are the only things that we're going to subtract. So here we had to do the 12 minus 2 to get 6, then subtract with your b's, where we can see that they all cancel out but 1. So if we look at number 9, 24 divided by 3 gives us 8, and 6 minus 2 gives you 4. That 4 does not apply to the 8, only to the x. So you can't say 8 to the 4th. This is 8 times x to the 4th. Here, number 10. Here's negative 6 over 5. If it's going to be a decimal, leave it in terms of the fraction. So this would end up being negative 1 and 1/5, or our decimal, okay, 0.2. We want to leave this as a fraction, unless it tells you to round. 9 minus 8 gives us 1. So you have y to the first up here. If you're not sure where it's supposed to go, think about writing them out. There's 4, 5, 6, 7, 8, 9 on top. 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. All of these cancel with all of these. You're left with 1y on the top. It has to go where you actually have numbers left. Okay, zeros as an exponent. This is the one that gets a lot of you. If this is 3 minus 3, you get 0. We cannot just write b, because we sit up here, anytime we have a single letter, it has an exponent of 1. So you can leave this as b to the 0 as your middle step, but then we need to simplify this to 1. That's one that's very commonly missed. Okay, if we have an entire list on here, I'm going to give you one more example. Let's say that we have 2, x to the third, y to the 5th, z to the 0, over 4x, y to the third. If we're going to simplify this, we're going to look at each part. Look at your numbers first. 2 divided by 4 reduces to 1/2. Look at your x's. 3 minus 1, we have the most on top, so we have x squared on top. Then look at the y's. 5 minus 3 is 2. We have 2 y's on top. Z to the 0 equals 1. We don't write it period. So the most simplified way we could write this answer would be to have x squared y squared over 2. Be very careful when you're doing division that you take care of your coefficients. You decide where you have the most of your variables or your numbers left, and that's where you write your answer. If you have numbers, then you can use your calculator to multiply these out and see what it simplifies to. So use these notes on your papers and look back at your examples.